Let's walk through the serverless architecture powering MedSimplify. It all begins with the client accessing the Flask frontend hosted on ECS Fargate behind an application load balancer. When a user lands on the home page, we open a WebSocket connection using API gateway and register their request ID along with a unique connection ID in the DynamoDB. Next, the user uploads a medical PDF through the loading route. The Flask app returns a pre-signed S3 URL and the user uploads the file directly into the S3 bucket. This triggers the extract text lambda function via an S3 object created event. It starts an asynchronous Textract job to extract all the text from the document. Once Textract completes, it sends a message to SNS, which then triggers our simplify medical text lambda. This lambda retrieves the extracted text using the job ID and sends it to Claude 3 on Amazon Bedrock using the messages API. Claude then responds with a simplified summary. The lambda stores it in the path summary folder in S3 and updates the request status in DynamoDB to completed along with the summary path. At this point, the broadcast lambda queries DynamoDB to match the request ID with the WebSocket connection ID. It then sends a real-time status update to the client, letting them know the summary is ready. Finally, the user is redirected to the results/request ID route where they can read their summary in plain language inside the Flask frontend. In total, we orchestrated 10 AWS services including S3, Lambda, API Gateway, Textract, Bedrock, SNS, DynamoDB, and ECS, all tied together in a serverless, scalable pipeline to deliver instant medical report to non-technical users. This is a demo on using MedSimplify and its user interface. The users can upload their medical report PDFs and hit on the summarize report. Once it is done, the document starts getting processed and it is shown in the display. Once the document is processed and the summary is written from Bedrock, it is shown on the display.